Now let's move into one of the biggest transformations happening globally, AI in manufacturing. Manufacturing is no longer about machines, assembly lines, and manual operations. Today, factories are becoming smart, connected, predictive, and increasingly autonomous. This shift is often called as Industry 4.0, where AI, robotics, IoT sensors, automation, and real-time data work together to create intelligent manufacturing ecosystems. The goal is simple: produce faster, reduce waste, improve quality, increase safety, and optimize cost. Let's explore some of the major applications. Number one, AI-enabled predictive maintenance. Traditionally, machines were repaired after they failed, but AI changes this completely. AI systems monitor the vibration, temperature, sound, pressure, and performance patterns to predict the failures before they actually happen. This reduces the downtime and saves millions in maintenance costs. Real-time process optimization using digital twins. A digital twin is actually a virtual simulation of a real factory in terms of the machine or the process. AI continuously analyzes real-world factory data and tests optimizations digitally before applying them physically. This helps manufacturers improve efficiency safely and quickly. AI for dynamic supplier selection and risk management, where AI can evaluate supplier reliability, pricing, delivery delays, geopolitical risks, and operational performance in real time. This helps companies make smarter sourcing decisions. We also have end-to-end supply chain visibility using AI, where AI provides real-time visibility across the supply chain from raw material to final delivery. It helps identify bottlenecks, shortages, delays, and disruptions early. We also have the automated bill of materials or BOM analysis, where AI can automatically analyze complex product structures and manufacturing dependencies, reducing manual engineering effort and errors. We also have energy consumption optimization, where factories consume enormous amounts of electricity and AI helps optimize the machine usage, the cooling, production timing, and energy distribution to reduce costs and improve sustainability. We also have the AI-powered safety monitoring via video analytics, where AI-powered cameras can actually detect unsafe behavior, missing safety gear, restricted area violations, or hazardous conditions in real time. Now let's move into the section of robotics and production intelligence, where we are talking about cobots with vision and speech recognition, where cobots or collaborative robots work alongside humans safely. Modern AI-powered cobots can actually see objects, they can understand voice instructions, and adapt to changing environments. AI for automated visual inspection and quality control, where AI vision systems inspect products far faster and more consistently than humans. They can detect tiny defects, surface damage, misalignment, or manufacturing inconsistencies instantly. Intelligent inventory management, where AI predicts the inventory needs dynamically based on sales, production schedules, supplier lead times, and market demand. This reduces both shortages and overstocking. We also have the generative design and product development, where engineers can now use AI automatically to generate multiple product designs based on the weight, the strength, the cost, materials, and performance goals. Sometimes AI can create designs that humans could never imagine. Computer-aided manufacturing CAM with AI enhancements, where AI is able to optimize machining paths, tool usage, manufacturing speed, and precision. This improves efficiency while reducing material waste. We also have the waste minimization through anomaly detection, where AI is able to detect unusual production patterns that may actually lead to scrap, defects, material waste, or inefficiencies. We also have the wearable tech with AI alerts for hazard detection, where workers can actually use AI-enabled wearables that monitor fatigue, heat stress, unsafe posture, or hazardous exposure in real time. Now let's move into the logistics forecasting and intelligent operations part, where we have autonomous material handling robots, where AI-powered robots can actually move material across factories and warehouses autonomously using sensors and computer vision. Demand forecasting using machine learning, where AI is able to predict the future product demand based on market trends, historical sales, seasonality, economic signals, and customer behavior. Then we have the logistics route optimization, where AI finds the fastest and the most cost-efficiency delivery routes while considering the traffic, fuel usage, weather, and delivery schedules. We also have the AI-powered simulation and prototyping, where manufacturers can test products digitally before physical production. reducing the development time and cost. We also have failure prediction in design iterations, where AI can predict which product designs are more likely to fail before the manufacturing begins. This improves reliability and reduces expensive redesign cycles. We also have AI in circular manufacturing and material reuse, where AI is able to help companies identify ways to reuse the materials, recycle waste, reduce emissions, and improve sustainability initiatives. And honestly, manufacturing may become one of the industries that's most transformed by AI in the next decade. Factories are evolving from manual operations to intelligent ecosystems. A future factory may actually include AI, robots, digital twins, predictive systems, autonomous logistics, and human machine collaboration, all working together continuously. But importantly, humans still remain critical. Because while AI can optimize operations, humans still need to provide the engineering creativity, strategic decisions, innovation, oversight, and problem solving. So, the future workforce in manufacturing will increasingly require skills in terms of AI literacy, automation systems, robotics, data analysis, IoT or Internet of Things, and digital operations. And just like other industries that we actually explored earlier, every topic here can become a specialization by itself, which is why we also offer dedicated masterclasses focused specifically on AI for manufacturing, which includes Industry 4.0, smart factories, predictive maintenance, AI robotics, supply chain intelligence, and industrial automation. So if you come from manufacturing, engineering, logistics, operations, or industrial technology, I strongly encourage you to continue into those specialized masterclasses, because the future of manufacturing may not just be about building products faster, it may be about building intelligent factories that continuously learn, adapt, and optimize themselves.